All right, this is going to be questions 21 through 25. 21, you want to know the increasing and decreasing intervals. So they're always going to be x intervals. So just make sure you're understanding their x values, not y values, okay? So the increasing intervals, we'll do that in purple, are going to be up as you go to the right. So that one here, which is going to be between negative 2.141, just use parentheses. And that's going to go to negative 0.541. Now there's another one over here, and that's going to be this one. Starting at 0.432, so you might see like a U there. And since it keeps going up forever, that's going to go to the right forever, and so infinity will be your end point for that. So it'll go on forever. Now your decreasing intervals are the other two intervals. We'll use yellow. So my decreasing intervals, this one right here, and this one. So since this one comes from the left side, this one comes from negative infinity. And that's going to end at this x value here, which is negative 2.141. Now it's going to join this decreasing interval, which is going to be from this negative 0.541 until it hits this x value at 0.432. So those are your decreasing intervals, and our increasing intervals were the ones up here in purple. That's number 21. Okay, 22, two functions are shown below. What is the y value when f of x equals each other? We're going to graph this again. So we want to know the y value. So let's put that in Desmos. All right, not necessary to say f of x or g of x. I'm just going to type 2x cubed plus 2x minus 3. And then negative 0.5, absolute value of x minus 4. And let's take a look at the graph here. These guys intersect each other right there. And so I'm going to go ahead and copy this graph real quick. So the answer to this question is going to be the negative 1.75, since it wants to know the y value. Where they equal each other, that's intersect. Your answer is negative 1.75. '23. If f of x equals k times x minus 2 to the fourth power, where k is positive, what is the effect on the graph of f of x as k increases? Well, this number right here, that's going to always be like your stretch or compress. So if k increases, that's gonna make it go skinnier, which makes it be vertically stretched. And so if you want to visualize that, you can graph it and you can kind of pick a number for k. So I started with 1, and you can see the graph here. Now, if I were to type that same graph in, but maybe make that number like 2, and then do it again and make it like 3, you're gonna see it's gonna be centered at the same place, but you know, let's make that 10 so you can really see, maybe 100, how skinny that gets, right? We call that a vertical stretch. So as k increases, it's going to stretch vertically. All right, number 24. Parent function f of x is transformed to the new function negative 3 f x plus 1 minus 6. Describe all the transformations. We're not given a function to graph, so we have to know the function rules. Anytime there's a negative, that's going to be a reflection over the x-axis. That's one transformation. The 3 itself is going to vertically stretch it. Remember, when that gets bigger, it vertically stretches it, just from the previous problem. That's going to be a vertical stretch. This is always the opposite, right or left, so that's going to be left 1. Remember, that's going to be opposite. And then this is going to be down 6, so that's going to be -6 outside. Now, if you want a function to play around with, my suggestion is to use x squared so you can see what's happening. So let me graph that and you can kind of see what's going on. All right, so let's say I pick like x squared as my function, you can see that's a quadratic. It's centered at the origin. If I've defined my x squared, now if I type negative f of x, there's your reflection. Now if I throw the 3 out front, it stretched it vertically. Inside, if I do +1, that took it to the left. And then if I do -6 on the outside, that took it down. And you can see it down here now. So you can see that difference, whether I did it like this, or, I mean, I could also have just done -3 parentheses x + 1 squared -6, and that's going to be the same problem as well. But now you can kind of compare those. So left, down, stretched, and reflected. Last problem. H of x equals 4x cubed minus 5x squared minus 23x plus 6. What is the distance to the nearest hundredth of a unit between the two zeros of h of x that are closest to each other? That's a mouthful. But what we're trying to do is get the zeros. So if you look at in this problem here, what are the zeros? That's going to be graph. So graph to get zeros. Since it talks about zeros, right? Between the two zeros that are closest to each other. So your first thing is to graph it. So 4x to the third power minus 5x squared minus 23x plus 6. Now this graph appears to give me 3 zeros. And what I want to do is I want to click on all of these to see where they are at. Now let's analyze those zeros for a moment. It says, what is the distance, the nearest hundredth of a unit between the two zeros that are closest to each other? So you got to decide which two zeros are closest to each other. These or these? So if I get this distance here, if I do like 0.25 minus -2, well, it's 2 to the left and 0.25. I just want to know like the physical distance. There's not going to be any negative signs here. That's going to be 2.25. If I look at the other two zeros, this one right over here, that's going to be 3 minus 0.25. And that's actually, well, that's 2.75, right? So these are actually a little bit further. And then these ones are closest. So the answer to the question is the one that's closest. It's going to be 2.25 units between these 2 points. So 2.25 is the answer. Units on the number line. Guys, I hope this was helpful. Your midterm will be similar to these 25 questions. Good luck.